Okay, so we're going to do an example of using the trapezium rule to approximate an area under a graph. Okay, so here's what I would like you to have a go at finding for me. Okay, it's the integration. I'm going to go between 4 and 0, and it's going to be 1 plus the square root of x all to the power of 3. Okay. Now, what we're going to do is this. We're going to find an approximate area for that. Find the approximate value using trapezium rule by breaking the area under the graph into trapezium. Okay. And then we'll get a value, and then we're going to see if we can actually integrate it using methods from C2 and see how close our actual answer is. Does that make sense? Okay. Now, firstly, just to help you out, I'll draw a quick sketch of the graph and talk about what we're doing. So, let's draw a graph of this. Okay. Now, can you tell me where it cuts, first of all? I mean, when x is 0, what value am I going to get out? 1. Yeah. Okay. So my graph actually starts at 1. Can you see that? And it's going to increase, and I think it's going to do something like that. Okay. And what we're going to do is we're going to break this into 4 strips. I would like you to do 4 strips. So that means that there's going to be strip here, strip here, strip here, and a strip there, and what the trapezium rule does is it finds the areas of trapezia like that. Now, first question is, when we do find our answer, okay, when we do find our approximation, is it going to be an overestimate for the area or an underestimate? It should be an overestimate if I've drawn the graph right. Okay, so what I'd like you to do is use the trapezium rule to find an approximation for the area under the graph. Okay, do you want me to write down the trapezium rule? I better do that. Okay, so the trapezium rule it's quite an easy rule to sort of prove. I mean, if you tried it yourself and just went along and said, okay, what's the area of this trapezium here? It's the height. Do you know how to calculate the area of trapezium? You add up the parallel sides. So you add up the parallel sides, times it by the distance between them, and then halve it. So if you went along and did all of that, you could do it yourself, but the trapezium rule is just essentially the same thing, but it's all written down in a formula. Does that sort of make sense? Okay, so we're just adding up the areas of all those trapezia along the way. Now, can you tell me what the formula is then? I think it's definitely in the formula book, and it's written down. If you want to integrate something between 2 values, and y is just, in our case, 1 plus root x to the power 3, it says that is approximately equal to, and that's that symbol there. Can you remember what the formula is? 1/2 h, yeah. 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 Yeah, the first y value plus the last y value. Yeah. Yeah, and then you just keep going until you get to the one before the last. Yep. Brill, well done, Josh. Is it? Okay, you didn't have to say that. Now, what's h? That's the only thing we haven't talked about. What's h? H is the distance between these. Okay, so our value of h is going to be what? What's our value of h? 1. Yeah, it's just a distance between 1. So where h is 1. Okay, so I'll give you a few minutes to do it. Okay, off you go. And we'll get a value, and then we'll see if we can integrate it and see how close our value is. Do ourselves a little table of x and y values that we're going to use. So the x values I'm going to write down like this. There's 4 strips, but that means there's 5 ordinates. And the ordinates are x0, x1, x2, x3, and x4. Okay. Now, if you look on the graph, these are just 0, 1, 2, 3, and 4. So I'll put those in. Those are the x values. And each one has a y value. So y0 is going to be the value when I sub in 0 into there. So what I'm going to do, I've got 1 cubed. Do you agree? What happens when I sub 1 in? Let's have a look. When I sub 1 in, I get 1 plus root of 1, which is just 1. So it's 2 cubed, so that's going to be 8. Okay, what happens when I sub 2 in? It's going to be 1 plus root 2 cubed. Can you just do that on your calculator? It's what, sorry? 7 plus 5 root 2. Okay. Should we just write it as a... Can you write it as a decimal, I think? It's fine using decimals here. 1 plus root 2, all cube rooted. Sorry, all cubed. Let's just put this one in. Is it? 14 point... Have you got the whole calculator display? So write it all down. 14.07106. 07... 10. Yeah. 61. Yeah. 81. 81. That's fine. Can you do the same for that one? 20.3923. 20.39. 23. Yeah. 04. Yeah. 85. 85. Okay, and this one is going to be 1 plus root of 4. Root of 4 is 2, so this is 3 cubed, which I can do, it's 27. Okay, so those are the y values, and now I just plug them into the trapezium rule up here, which you get in the formula book. So what we're saying then is, let's come down a little bit. We think that if I want to integrate between 4 and 0, 1 plus root x all cubed, the answer is approximately equal to a half of h. Well, h was just 1, wasn't it? So this is just a half times the first y, 1, plus the last y, 27, plus 2 lots of all the other ones. So 8 plus 14.07106,781 plus 20.39230485. Okay, just write that in your calculator. So I would do the 2 times all of this first, then add on 27, then add on 1, then halve everything. .56. Yeah. 66. Yeah. And should we go to 2 decimal places? So 56.46. Now, when I drew the graph, we were doing the trapezium on there, and we said if the graph's right, which I don't know, I think it might be a bit straighter than that. But if the graph is curved like that, it's going to be an overestimate, yeah? If the graph is curved like this, it's going to be an underestimate, okay? And how could I make it more accurate? Use more strips, yeah. So what we're going to finally do is we're going to see if we can actually integrate that, okay? You guys got a couple of minutes? Okay, so now usually given things to you use trapezium rule on things that you can't integrate. Do you see what I mean? Because if you could integrate it from the area, your answer would be better. It would be more accurate. So usually you use Trapezium Rule on things you can't integrate. But I've picked a question that, though it's not very nice, it is possible to integrate. So should we try and integrate it and see how close we are? Can you integrate that? How would I do it? What's the problem with it at the moment? It is hard, yeah. Why is it hard? What do you need it to look like before you can integrate it? What sort of form do you want that to be in? Not a bracket. You want it all linear, yeah? Okay. So, can I get it out of a bracket? Any ideas? How could I get rid of that bracket? I could times it all out, yeah? Definitely could do that. It'd take a bit of time, yeah? But there's a way that we can multiply out brackets very quick on C2. Do you remember what it's called? It's called the Binomial Expansion. Okay. So can you remember how it works? Okay. Let me do it quickly. I'll let you look it up, okay? So again, it's in the formula book. It's always 1 plus something. And what you usually do is let me do. In fact, I'll do it. You got a couple of minutes, you sure? Okay. What I'm going to do as an aside, I'll do it down here, but then I'll plug it in up here. If I wanted, usually, I would do it like this. I would do the expansion of 1 plus x to the power of 3. And I'd find out what it all was. And then what I'm going to do is change all the x's for root x's. Does that make sense? Do you remember doing that? I'm going to do the expansion of 1 plus x to the power of 3, write it all out. And then wherever I see an x, I'll swap it for a root x. And it will be the same thing then, won't it? You understand what I mean? So this thing here is going to be x cubed, yeah? Yeah. Plus 3x. Yeah. Plus, yeah. Not plus 3? Yeah, plus 1. So you could do it, yeah? Yeah, perfect. So what I'm going to do here then is this thing I'm trying to expand here is the same as that, except it's not x's, it's root x's, isn't it? Okay. So what am I going to get? I'm going to get root x cubed. To do that, plus what? Plus 3 root x squared, yeah. Plus 3 root x, yeah. Plus 1. Okay. So I could do it, yeah? And in fact, that was pretty impressive, I thought. Okay, now, I'm going to come down here then, because this bit was like what we had to do. I'm going to come down here. Now, it's still not quite in a way I want to integrate it because of all the roots. Okay, so let's see if we can do anything with the roots. X, the square root of x, I can write as x to the half, can't I? So what's x to the half all to the power of 3? Yeah. So this is just x 3 over 2. Okay. What's 3 root x squared? Squared? Yeah. Root x squared, isn't it? Okay. But you did it with the indices, yeah? 2 over 2. Okay. So that's just 3x. This one's going to be what? Real. And then we just got 1 on the end, right? Can I integrate that? Yes, so shall we do it? Okay. Okay, come on then, Bex. X to the power of 3 over 2. Okay. I'm going to add 1 to the power. It's x to the power of 5 over 2. Excellent. Over 5 over 2. We'll sort that out in a minute, yeah? That 5 over 2 on the bottom, we'll sort it out in a minute. What's this one integrated? Yeah. Real? What's this one integrated? Over 3 over 2, yeah. And what's the last one integrated? It's just x, yeah. Perfect. And we've got these limits now, yeah? Okay, absolutely perfect that is. So I'm just going to tidy it up one more time before we sort it all out. X to the power 5 over 2 over 5 over 2. Yes. You've been listening today, right? That's excellent, that is. And this one doesn't have to do anything to it. No? This one? Yeah, 6x to the power 3 over 2 over 3. What's 6 over 3? Nice. Amelia, that's really good, that is. And that one I don't have to do anything with, do I? Brilliant. So, what we're going to do is we're going to sub 4 and 0 in, and then we'll get our answer. Okay? So, if I sub 4 in, I'm going to get... Now, remember, it doesn't matter whether I do power 5 first or the square root. So, what's the best thing to do first? Square root. So, the square root of 4 is 2, and then it's going to be 2 to the power of 5, which is 32. Well done. And then you times it by 2, 64 over 5, I think. Okay? Happy with that? I'm going to get 4 squared, which is 16, and I think I'll halve it first, so that's going to be 8. So it's 3 times 8, which is 24, I think. Agree with that? Okay. Now again, it doesn't matter whether I do the cube first or the square root, so I'm going to do the square root first, which is 2, and then cube, so that's 8. So 2 times 8, 16. Yeah? And then finally, plus 4. And then I'm going to take away when I sub 0 in. However, sub 0 in to all of that, what do I get? 0, so I don't even have to worry about it. Okay? So all I've got to do is just add this bit up. So it's going to be 64 over 5, and I'll add all this bit up. That's 30, 40, that's 44, I think. Is it? Okay, we'll just add those bits up. What do you get? 10, 12, 12 and 4/5, is it? I think that's 12.8 plus 44. 56.8. Brilliant. So that's what we got when we integrated. What did we get when we did the trapezium rule? 56.4. Okay, did we say it was going to be an underestimate or an overestimate? We said it over. So what does that tell you about my graph that I drew? It should bend the other way. Okay, good. Good. Well done on the integration. Very impressive, that is.